How can you avoid situations like this, or this one here? Google Cloud is an awesome platform for data scientists, developers, and startups, but if you're not careful, it can very quickly break the bank, as many Reddit anecdotes can confirm. Hi, my name is vdantas, and I'm a solutions architect at Google Cloud, and this is my ugly face. In this video, I will give you some tools and strategies to prevent large unexpected bills on Google Cloud. First, I will share with you a Cloud Function script that will automatically shut down your billing account should your cloud consumption exceed the threshold you define. Then I'll also share what are some of the silent bill bombs on Google Cloud and give you my top tips for preventing costs from getting out of control. Okay, let's start with the number one thing you can do to prevent a hole in your bank account, and that is implementing a kill switch that will automatically disable your billing account if things get crazy. Now, before I do, a word of caution. There's a significant delay from the time you use a service to the time the service cost is reported to cloud billing. It can take hours and in some cases more than 24 hours. This means that by the time you delete your billing account, it might be too late already. But that is why I'm also going to share additional tips and other things you can do. And here's a second warning. If you do remove cloud billing, all your resources will be shut down. Even if you go and re-enable cloud billing, there is no guarantee that you'll be able to recover your resources. Alright, with all of that being said, let's get into it. The first step is to enable the Cloud Billing API. To do so, simply type Cloud Billing API in the search box here and click on Enable. It might be that this API is already enabled for you, but if not, make sure you do that. Step 2 is to create service accounts that we're going to need for our function and for PubSub. Right, let's navigate over to IAM. And we're going to go to the service account menu here on the left. Click on create service account. So first we'll create a service account for invoking the function. Give it the role of Cloud Run Invoker. And that's about it. Now we'll create a service account for the function. And this one should have the role of Project Billing Manager. And one more thing we need to do here, we need to copy this service account over here, go to Billing Accounts, Manage Billing Account, and then in the billing account, we add the service account principal here with the role of Billing Administrator. Alright, the next step is to create the PubSub topic. This is where we're going to be sending budget alerts and where we're going to use to invoke our function to disable billing. So we create a topic. I'll give it the name of budget alert topic. And you can leave all of the configurations here with the default values. Now we'll create the Cloud Run function and configure a PubSub subscription. Okay, so we're in the Cloud Run console here. We click on Write a Function, make sure we have the function option selected here. We'll give this the name of Billing Kill Switch function. I'll choose Python as the runtime. Click on Require Authentication. And put a maximum number of instances at 1, so we don't have any more than just one instance running at any time. Then we need to create one environment variable here called project ID, and with the value being your project ID. Next, let's go over to security and change the service account to the one we created previously, which is the Billing Kill Switch SA. With that, we can click on Create. And now we can use the inline code editor here to paste in our code. You have access to this code in the repository linked in the video description, so make sure you go and grab it. We also need to make sure we update the function endpoint name here to stop_billing, and we add one dependency here that we're going to need for our function. Now, while the deployment is happening here, let's copy the function's URL, and we're going to go back to PubSub. So in here, we go to subscriptions, create subscription, select the topic that we created earlier, set it as a push subscription and paste the URL in here, and then enable authentication, and then select the service account that we created earlier, the kill switch invoker SA. We can leave all the other options with the default values and click on create. All right, the final step is to create the budget and configure the alert. So we go to billing budgets, we create a budget, give it a name, and you can specify which projects are in scope here. Click on next, then determine the amount. This is a monthly budget amount from here. I'm just going to put a fairly low value, and then specify at which points do you want to receive alerts. I'm just going to leave one alert here at the 90% mark, or let's make it 80. Now in the notifications section here, we need to connect the PubSub topic to this budget. So we select this option. And then we select the topic that we created. Now, if you don't see it here, you may need to click on switch project and select the project where the topic was created, and then finish. And now we have it all set. All the plumbing and the automation is set up. We can try and test it by going over to PubSub and to the topic and messages. And we can click on publish message, and I'm going to paste in a sample payload here. Keep in mind, if you do this, your billing account will be disabled. So don't test it unless you're sure you are okay with that happening. And now we can go over to our Cloud Run function logs here to see that it has been executed and that the billing was disabled. And we can see that it worked really well here. And we can check that it indeed has been disabled by going over to the billing account. And we can see now that we don't have any billing account. Okay, so it's worth reminding everyone again that this solution will permanently delete resources and data, and it's unlikely you will be able to recover them. It's a great solution for personal experimentation and learning, perhaps not if you're a startup hosting a SaaS application in production. But stay tuned, because I have a bonus tip for startups at the end of this video. Now here are the top 5 things you can do to prevent unexpected bills. Number 1 is enable multi-factor authentication. If the user account you use to log in, whether it's your personal Gmail account or a corporate account, doesn't have multi-factor authentication enabled, please do so immediately. There are a million different reasons why you should do it. Preventing unexpected cloud bills is one of them. Why? Because oftentimes the reason people get unexpected bills is because their account has been hacked, and someone went to your cloud environment with your account and created virtual machines or other resources without you knowing. Number 2 is do not export service account keys. Service accounts are the identities used for non-human users. For example, if you want to set up a GitHub action that connects to your Google Cloud project to create resources, you may be tempted to export the keys of a service account that has the required permissions and use those keys in your GitHub action workflow. You may find some tutorials on the internet that tell you to do that because it's easy and convenient, but don't do it. Service account keys are the credentials used to authenticate your service account, and if someone gets a hold of it, because for instance, you accidentally committed it to a public repository, they'll be able to do everything the service account has permissions to do. So for these kinds of scenarios, consider alternatives like workload identity federation, which is a much better, more secure way of providing access to external systems. And also only grant the minimum set of permissions required for the service account to do its jobs. Alright, on to tip number 3. Be aware of silent bill bombs. These are things that can rack up an enormous bill in just a very short amount of time. The top 3 bill bombs are: number 1, BigQuery. Remember that Reddit story I showed in the very beginning? Yes, it was caused by BigQuery queries against large public datasets. If you plan to work with BigQuery, check out the documentation on optimizing query computation. It will teach you a number of things from avoiding select star and using the where clause to anti-SQL patterns you should avoid. The second one is public cloud storage buckets. If you create a bucket and do not enforce the public access prevention, which is the default configuration, or if you deliberately make it public just to make it easier to access the data in there, you need to be aware that you pay for egress costs for data leaving your buckets, meaning that if a lot of people happens to download data from your buckets, you're going to be paying potentially a lot of money. If you do need the data to be public, then monitor usage and pay attention to anomalies. The third one is really just large virtual machines that you might have created for a specific purpose and maybe forgot to delete. I'll come back to that in a moment. Next tip is to enforce guardrails. On Google Cloud, you can implement guardrails in the form of organization policies. For example, disable service account key creation is a great policy to enforce to prevent that from happening. Other policies you should consider enabling would be disabling public IP addresses on virtual machines, restricting the regions where resources can be deployed on, or even what kind of Google Cloud services can be used. Another thing you can do is enforce lower quotas than the default quotas you get for service consumption. The quotas are very granular in Google Cloud, so you can, for instance, dictate how many external IPs, SSL certificates, or networks to have, or even specific CPU types in specific regions. Now here's a useful one for you. If you're not scared of BigQuery, consider lowering the query users per day quota, which by default is unlimited, to a value determined in terms of terabytes of data queried, and put a value here that you consider reasonable for you. That way, if you accidentally run a select star query on a very large dataset with petabytes of data, that request is going to hit your quota and fail to run, or at least fail to run completely, saving you a lot of money. Alright, last but not least, regularly check for idle resources. A common cause of unexpected bills or idle resources that you left behind, typically virtual machines. In Google Cloud, you can navigate to the recommendations section and the costs menu specifically to see if there are any cost recommendations. These could include idle resources that you have left behind that the platform detected them as idle resources, or even virtual machines that are potentially oversized. Alright, I promised one bonus tip for startups, and here it is. You can apply for the startup program, even if you are early stage and pre-seed, to get some significant amount of credits to deploy and test your idea. Of course, it's not guaranteed that you're going to get it, but you should absolutely try it if you're building a startup. These will be credits that are valid for a year or so typically, so you will have plenty of time to optimize your solution for costs while absorbing any unexpected bills through your credits. That way, you don't need to create a risky cloud billing kill switch script that could completely erase your progress. But keep in mind, you should still do all of the other things that I mentioned here, and probably a lot more. There is a lot to cost optimization and cloud FinOps that I did not cover, and perhaps in a future video I will. In this video, I try to focus on the top things that you can do as an individual using your personal account or as a small startup to prevent large unexpected bills. Now, I hope you find it useful, and if you do, save a Nerd Friends bank account by sharing this video with them. Or just like the video to give me a quick and easy signal that this is the kind of content you want to see. Thank you for watching.